Hello friends, in this video we will study heat balance sheet of an IC engine. So this heat balance sheet is very similar to the balance sheet in account section. So what is heat balance sheet? We will see. Heat balance sheet means it is a sheet or it is an account of heat supply by combustion of fuel and heat expenditure in various ways of system. So generally heat is produced by the combustion of fuel. It may be petrol engine, it may be diesel engine, or it may be gaseous engine. So fuel is burnt. After combustion of fuel, tremendous amount of heat is generated. That heat is converted or is supplied to various systems. So that system, first of all, that heat is converted into mechanical work. Heat is converted into mechanical work means a shaft rotates continuously, crankshaft rotates continuously. That crankshaft is coupled to one of the wheel. Second thing, we use cooling system. Whether it is a light commercial vehicle, whether it is a two-wheeler, whether it is any engine, we require cooling system. So that coolant carries heat from engine cylinder. This is the second thing. Third thing is exhaust gas. So almost 40 to 45% heat goes as waste through exhaust gas. So this is next important parameter. And fourth important parameter, the unaccounted heat. The heat which we don't consider, that is by convection or by radiation, heat is wasted into the atmosphere. It is exhausted into the atmosphere. So the amount of heat supply, let's say it's a QS, and the amount of heat utilized, that is heat utilized, let's say it's a QU, a sheet which represents the amount of heat supplied and amount of heat utilized. That sheet is known as heat balance sheet. Okay, now how to prepare heat balance sheet we will see. So how will we find out heat supply to the system? For that purpose, we must know how much amount of fuel is burned in combustion chamber. So that is mass of fuel we must know and its calorific value. So if you multiply a mass by its calorific value, we will get heat supply. So heat supplied QS is given by mass of fuel burnt multiplied by its calorific value. What is the meaning of calorific value? Calorific value means the amount of heat liberated or generated by burning 1 kg of fuel. It means that if you multiply calorific value by its mass, you will get the amount of heat supplied. So this is the first important formula in the heat balance sheet. This is the amount of heat produced. This heat produced is supplied to various systems. Means the amount of heat is converted into brake power. So here first utilization brake power, or here we will write the amount of heat utilized in, here we will write heat utilized in brake power. Heat utilized in brake power. In earlier lecture, we studied how to determine brake power. So brake power can be calculated by using dynamometer. So brake power is calculated by 2 pi nt upon 60. Okay, if you want in kilowatt, multiplied by 1000. So generally, this QB means heat utilized in brake power. So formula is brake power multiplied by 60. This power will be in kilojoule per minute. Here also, heat balance may be drawn by three various methods. That is on minute basis, on second basis, or on hour basis. So this heat balance sheet is on minute basis. Means in 1 minute how much amount of heat is produced. Similarly here, if you want this heat balance sheet in minute basis, this mass flow rate must be in kg per minute. This is the first utilization of heat. Okay, so why to multiply by 60? Because brake power is in kilowatt. To convert this kilowatt into kg per minute, we have multiplied by 60. Second, heat utilized or heat carried away by cooling water. Heat carried away by cooling water. Let's say we will call it as QW. Heat carried away by cooling water. So generally, if you supply heat energy, the formula is mCdT. Now whether it is a pressure remain constant, whether it is volume remain constant. So depending upon that, we write it as Cp or Cv. So here we will write mass flow rate of water multiplied by Cp of water multiplied by temperature difference, that is inlet temperature difference and outlet temperature difference of engine cylinder, that is T2 minus T1. T2 minus T1. So some part of heat which is generated is carried away by cooling water. Third, heat carried away by exhaust gases. So heat carried away by exhaust gases, the formula remains same. Instead of water, we will write here QEG. So heat carried away by exhaust gases is equal to mass of exhaust gas, Cp of exhaust gas into final temperature, that is T exhaust minus T atmosphere. This is another important formula, is the amount of heat is carried away by exhaust gases. And fourth important formula, unaccounted heat. Unaccounted heat means the heat which is not considered in previous. So QU is equal to, or we will use another QH, unaccounted heat. QH is equal to QS, that is heat supplied minus summation of these three. Okay. Unaccounted heat transfer generally takes place by convection or radiation directly from engine. Means QS plus QB plus QW plus QEG. This is unaccounted heat formula. Now how to prepare heat balance sheet? So I'll modify these formulae into heat balance sheet. Heat balance sheet means this is the amount of heat supplied. Means 100% heat is produced here. 100% heat is produced. So heat supplied QS is equal to QS upon QS into 100, means 100% heat is produced here. 100% heat is produced, out of which first heat is utilized for brake power. So convert this QB into its percentage. So QB, it is percentage, QB upon QS multiplied by 100. It will give you how much percentage of heat is converted to brake power. Next, QW divided by QS into 100. How much amount of heat carried away by cooling water? QEG upon QS multiplied by 100. How much amount of heat carried away by exhaust gas? Similarly, here QH divided by QS multiplied by 100. So denominator remains same, that is QS heat supply. Only numerator we have to change. For brake power QB, for heat carried away by cooling water QW, we have already calculated here. Put that value here, divide by QS multiplied by 100. It will give you in terms of percentage heat carried away by exhaust gas QEG. Use this formula, determine QEG, put it here, QEG upon QS into 100. Next, unaccounted heat. This unaccounted heat is calculated by adding these three and subtracting from QS. This is unaccounted heat. So unaccounted heat in terms of percentage is QH upon QS into 100. So how to balance this? So 100% heat is produced and 100% heat is utilized. So heat utilization, that is QU, must be 100% as heat supplied is 100%. This is all about heat balancing. In the next video, we will see the numerical based on this heat balance sheet and how to prepare heat balance sheet. Okay, thank you.